Okay, I wanted to check out C here, and okay, first, let's do this not with X, but let's do it with Y equals, well, that's a really thin marker. Y equals, we'll say -3. Okay, so if our axis of revolution was -3, hopefully my throat stops tickling here. Y equals -3. How would we find the volume that's generated when we revolve this area around that? Okay, now remember, because we have two curves, we have x squared and we have 4, we're gonna have to use the washer method. If we just had one curve, then we would just, let's say we just had this curve right here, the y equals 4. If I revolve this around this axis of revolution, it would make these circles, okay? Now to find this radius, I would have to do top minus bottom to find my radius. So that would be 4 minus -3. And that makes a lot of sense. I think to you guys, you would get 7, r equals 7. You're like, oh yeah, no duh. Then all you would do is you would square the 7 and then multiply it times pi, and that would be the area of that circle. Now, for this constant function, the areas of those circles aren't going to change. And so there is a shortcut way to do it without calculus, but I'm going to keep using calculus just because, just for the sake of learning here. Okay, so we're not doing this. We did this in the other video. Okay, so we would sum all of the circles from -2 to 2, and we have to find -2 and 2, of course, by seeing where these intersect, these two curves. We found that in another video. And then I would sum the radius squared and then multiply it by pi. I am being a little excessive here, but that would be the disk method just for the outer function. For the inner function, let's draw another circle here. We'll say when we revolve this curve around that axis, right, it would look like this down here. Oh, wow, that's an upside down parabola. So I'm just trying to copy that parabola down here. And then we would be getting these circles to make this solid. Okay, wow, that's looking kind of confusing. But anyways, in order to find this radius, I would have to do top curve, outer curve, minus the axis of symmetry. So my outer curve is x squared. And then I would have to subtract the axis. I keep saying axis of symmetry. It's axis of revolution to get the radius. Now that's your radius. You're supposed to square it and then multiply it times pi. Now this is a function. It says x squared. So what we're going to do is we're going to plug in x values from -2 to 2. And we're going to add them all together. That's what the integral will do. So this is the volume of the outer curve, in which case it's y equals 4, and it's outer because it's farthest away from my axis of revolution. And this is the volume of the inner curve. All right, x squared, that's this guy right here, he would be the inner curve because he is closer to the axis of revolution. Now, because the lower and upper bounds are the same, we could simplify this. We could say pi from -2 to 2, and then we have our radius, which is 7 squared, minus our other radius, which is x squared minus or plus 3 squared, and then we have our dx. I'm going to go ahead and bracket this to indicate that is our integrand. And if I did that, which I can do, I would find the volume of the solid that is formed when revolving this area around this axis of revolution. All right, so let's go ahead and do this for funsies. Okay, so we have pi, -2 to 2, 49. Oh man, we're gonna have to square that. So it's gonna be x squared plus 3 times x squared plus 3. So that's gonna give me x to the 4th plus 3x squared plus 3x squared. Oh man. X squared, and then plus 9. All right, so that's going to be 6x squared. So I have minus x to the 4th minus 6x squared minus 9. So this is actually going to be a 40 right there. Ooh. All right, let's just keep going here. Pi, -2 to 2. we have 40 minus x to the fourth minus 6x squared dx. That's my integrand. Let's anti-derive this foo. So we have pi integrand. We have 40x minus x to the fifth divided by 5 minus 6 divided by 3, because that's x to the third. And then we're going to have to plug in 2 and negative 2. Oh, man, this is not getting better. It's getting uglier. So we have pi times, all right, plugging in 2. We get 80 minus, let's see, 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32. So we get 32 over 5 minus 6. And then 2 times 2 is 4, times 2 is 8. So it's 8. No, not 6. It's going to be 2. 2 times 8. And then we're going to subtract, big parenthesis. Now I'm going to plug in negative 2, so I get negative 80. And then that's going to be a negative 32 over 5, which would make it a positive. And then minus 2 times, and that would be a negative 8. Wow, all these negatives. Oof, lots of places to make mistakes. All right. Now I have to simplify. It's right, but dang, oh, this is disgusting. Let's distribute this negative. This would be a positive because, so we positive 16, and then it would be back to negative because I distributed a negative. Okay, so, and this is going to be negative 16. So we have, oh man, it's like everything doubles. So we have 160 minus 64 divided by 5, and then minus 32. Oh, and we can subtract that from, dang it. So it would be 128 minus 64 over 5. And I'm just going to leave those guys right now and multiply that by pi and say this is my answer. All right, it's simplified enough. We don't need to go any farther than that.